Remember that we've now done the techniques of integration by parts to find an antiderivative or to find the class of antiderivatives. With all of this, and this includes any integration technique we do, we can always turn these into definite integrals and evaluate definite integrals using the techniques of integration by parts. Let's go ahead and evaluate this definite integral using integration by parts. What we'll need to do is we'll need to find an antiderivative, and then once we found the antiderivative, we plug in 2 and plug in 1 and then subtract our numbers. Let's go ahead and do that. What I would do is focus on finding the antiderivative first using the integration by parts techniques. Because this is polynomial times natural log, our f prime is going to be our polynomial, and our g is going to be the natural log. F, therefore, would be 1/4 x to the 4th. G prime would be 1/x. This expression has antiderivative of f times g, that's 1/4 x to the 4th, multiplied times natural log of x, minus integrate f times g prime is 1/4 x to the 4th, multiplied times 1/x with respect to x. Now, I have conveniently left off the 2 to 1 because this kind of mixes an integration with a piece we've already integrated. So I am purposefully leaving off the bounds right now until I get to a further step. In particular, I'm waiting until after I've integrated this to plug in and put in those bounds. Here we have 1/4 x to the 4th natural log of x minus integrate 1/4 x to the 3rd. Now we can integrate that function on the right. When you raise the exponent by 1, you get x to the 4th. When you divide by 4, 1/4 divided by 4 is 1/16. And it's at this point that we can put in the bounds. Since this is a definite integral, we are going to take this thing bounded from 2 to 1, or from 1 to 2. Recall that I can put in any constant that I want, so I'm going to put in a constant of 0. Now I can simply plug in 2 and plug in 1. Let's plug in 2 first. 1/4 times 2 to the 4th times natural log of 2 minus 1/16 times 2 to the 4th. And that's all going to be evaluated. And then I'm going to subtract what I get when I plug in 1. So I just take my antiderivative, plug in 1 every time I see an x. And then I type that in on my calculator. Because of the natural log, this is going to have some ugly decimals with it. You could, if you wanted to, give an exact answer, but it would involve natural log of 2 and natural log of 1. Now, natural log of 1 is just fine. That's just a 0. But natural log of 2 is a number that is a big, ugly decimal. To spoil plugging it in on my calculator, I ended up with about a 1.835088, so on and so forth. This decimal was rounded, so it'd probably go on forever. Moodle is probably going to ask you to round it to approximately 2 decimal places or something like that. If it asks you to round it to 2 decimal places, obviously that's a 1.84. If it asks you to round it to 3, 1.835, something like that. So this is the way to do definite integrals when we have to use integration by parts. Again, don't try to use the bounds in the middle steps. In the middle steps, just go ahead and find an antiderivative that you want to use and then put in the bounds. Very similar to substitution. We kind of ignore the bounds for a little bit, and then once we get back to the actual antiderivative we want to use, then we plug in the bounds. This is the way to do these types of definite integrals with integration by parts. We've seen quite a few techniques of integration. We've seen a lot of basic rules in this class. We've seen a lot of substitution in this class. And we've seen some integration by parts in this class. I want to also just make you aware these are not the only techniques that can be used. Substitution and integration by parts sometimes together, or either or, could have been used to solve this problem. But that's not the only way to solve this problem. It turns out there's other ways to solve this problem as well. And there are some ways in which substitution wouldn't work, and some problems where integration by parts would not work. Those advanced techniques you may see if you go into a Calc 2 class. That's what Calc 2 is about, at least in this college. It starts out dealing with integration techniques, more advanced integration techniques. In Calc 1, we just stop here. We say, well, we want to deal with integration techniques of our basic rules plus our substitution plus our integration by parts. And that concludes this section.